So we're going to break up our rules and our practice for writing names and formulas for ionic compounds into three categories. The first category we're going to look at are just called simple ionic compounds. So they're our most basic ones. The next section we're going to look at are how to write formulas and names for ionic compounds with transition metals. And then we'll finally come back and look at those polyatomic ions that were mentioned previously. But for right now, we're just looking at simple ionic compounds. So remember, an ionic compound contains a metal and a nonmetal, a positive and a negative charge. So we have rules when we write the names and we have rules when we write the formulas. Our first rule has to do with the order. We always write the metal first and then we write the nonmetal. This goes for both the name and the formula. So the metal part is going to come first. Remember that that is our positive charge. And our nonmetal is going to come second. That's our negative charge. So it always goes metal, then the nonmetal. We also have to talk about how we end the name. This is specific for when we write names for these different compounds. So we leave the name of the metal just as it is. Whether it's sodium, calcium, potassium, we leave those as they are. But we change the ending of the nonmetal. We take off the end of the name of the nonmetal, and then we add IDE. So if it's oxygen, you take off the end of oxygen and turn it to oxide. If it's phosphorus, you take off the end of phosphorus and add phosphide. There isn't really a good set rule for how many of the letters you take off. That's something that will come with practice. As we do more and more of these, you'll see where it's natural to change the ending to "ide." And then our last rule is that our charges must balance. Our overall compound, regardless of what components it contains, has to be neutral. So if we have two positive charges, we have to have two negative charges. If we have one positive charge, we have to have a total of one negative charge. So we have to make sure that overall our compound is neutral. And we're going to use our periodic table to remind us of our charges. So we have three rules. We have the order that we write things in, both the names and the formulas. It goes metal, then nonmetal. We have the ending for the name. We basically change the end of the name of the nonmetal to IDE, so oxide, phosphide, sulfide, things like that. And then our compounds must be neutral, so our charges have to balance. Our amounts of positive and negative charges must be equal. So let's walk through some examples, because that's the easiest way to put these rules into practice. So our first example has sodium and chlorine. So we're going to practice going from formulas to names. So we're going to take our formula for sodium and chlorine, which is NaCl, and we're going to break this apart and let's practice how to write the name for this. So the first symbol, our metal, is sodium, so that's what we write first. And then chlorine is our nonmetal. Oops, helps if I can spell. Now, it's not sodium chlorine. Remember, our second rule is that we have to take off the ending and change it to IDE. So we have sodium chloride. That's all it is. That's the name, sodium chloride. So NaCl is sodium chloride. Now, we don't have to worry about the charges balancing for the names. That concerns the formulas. So we've accomplished our two things. We have the metal, then the nonmetal, and we've changed the ending of the nonmetal to IDE. That's it. Let's look at our second example. So we have calcium and oxygen. So calcium's going to come first. Since it's our metal, we just leave its name as it is. And then oxygen. Now for oxygen, it's this whole ending that comes off. And this gets changed to IDE. So we can think of it as, let's just erase this and rewrite it. Calcium oxide. So we have our metal, then our nonmetal, follows the same order as in the formula. Calcium, that word stays the same, and then oxygen changes to oxide. Let's look at our third example. We have magnesium and two chlorines. So we're going to follow our rules. Magnesium comes first because it's our metal. And then we have chlorine. And just like before, chlorine take off the ending and it changes to chloride. So we have magnesium chloride. Metal comes first, then the nonmetal, and we've changed the ending. Note, it's not magnesium dichloride or anything like that. This 2 has no effect on this name. This 2 just tells us that for every 1 magnesium, we have 2 chlorines, but the name is still just magnesium chloride. So now that we've done some practice writing names, let's go the other way. Let's practice writing formulas. So our first one, potassium oxide. So we're going to take our name and we're going to write our symbol. So K is for potassium. And potassium, when it's an ion, it's in the first column of the periodic table. So that means it has a +1 charge. And then oxide is oxygen. And oxygen, because of its column on the periodic table, has a -2 charge. Remember, it goes +1, +2, +3, ±4, -3, -2, -1. So oxygen is in the -2 column. Now, when we go to actually write the formula, we can't have charges. It has to be neutral. So if we have 2 negative charges and 1 positive charge, how many more positive charges do we need? Well, we need a total of 2 positives to balance out the 2 negatives. So we need 2 potassiums to go with our 1 oxygen. So it would be K2O. The other way you can look at this is you can swap where they're located. So the 2, that's the superscript on the oxygen, will become the subscript on the potassium. And the 1 that's the superscript on the potassium will become the subscript on the oxygen. Notice we don't write the 1. Just by writing the O for oxygen tells us that there's 1. So we don't write the 1s. Let's look at a different example. So let's look at magnesium bromide. So magnesium is Mg. If we find it on the periodic table, it's in our second column, so it has a +2 charge. That's using the periodic table to get us to our charges. And then bromide is bromine, which is Br, and it's in this column over here, so that tells us that that's a -1 charge. Now we can think about it in our 2 ways. We can either say, how do we get our +2 to balance with our -1? Well, we need twice as much negatives. If we have 2 bromines, we have a total of -2 to balance out the +2 from the magnesium. Or you can say the superscript from the magnesium is going to become the subscript on the bromine. The superscript from the bromine is going to become the subscript on the magnesium. So those are our 2 ways to think about it. So MgBr2 is magnesium bromide. Now let's look at our last example, aluminum phosphide. So aluminum is Al. On our periodic table, it's in the third column that has the +3 charge. Phosphide is phosphorus, so P. Based on its location on the periodic table, it has a -3 charge. Now, when we look at this, our charges are already balanced. Our aluminum has a +3, our phosphorus has a -3, so we can just write AlP, because they're already equal. We only need 1 aluminum and 1 phosphorus for this to be neutral. Now, if you swap them, you would think that it would be Al3P3. All we've done is reduce the numbers. We want the lowest ratio when we write the formulas. So we reduce 3 aluminum and 3 phosphorus to 1 aluminum and 1 phosphorus, and that gives us our formula for aluminum phosphide. So all you have to do when you practice is follow these rules. It's just a pattern. If you know the rules, you know your symbols, and you know your charges, you can write formulas and you can write names for ionic compounds.